The warm-up for lesson 54, geometric sequences, is the sequence 11, 22, 33, 44. Is it arithmetic? So what do we do if we can, to tell if a sequence is arithmetic or not? It will have a common difference. So what are we doing? We're adding 11, adding 11, adding 11. Whole bunch of unsmiley faces there, it looks like. We're just adding 11 each time. So yes, that's arithmetic. Write a rule for the nth term of the sequence. So what are we doing here? Looks like we're subtracting 6 each time. So and then we want to find the 20th term. So our rule, right, a sub n equals the first term plus the quantity n minus 1 times our common difference. So we're going to say a sub n equals, what's our first term, is 30, plus the quantity n minus 1 times our common difference, which is negative 6. To simplify this, we'll distribute our negative 6. So we get 30 minus 6n plus 6. And then we will combine our like terms, so we get negative 6n plus 36. So then to find our rule, or to find our 20th term, we'll plug in a 20 in for n in our rule. So a sub 20, the 20th term, is negative 6 times 20 plus 36. So the 20th term is negative 120 plus 36. So the 20th term is, what is that, negative 84. One term of an arithmetic sequence is, so the 15th term is 20. The common difference is 1/2. Write a rule for the nth term. So we could say that our 15th term, so that means that you know, that's a point. That's 15, 20, and our common difference is 1/2. So that's the same thing as having, if we were talking about slope-intercept form, that's a rule too. So we're saying the 15th term, and so what is our common difference? Our common difference is the slope. So 1/2 times 15 plus b. So what is half of 15? 20 equals 7.5 plus b. Subtract 7.5. Subtract 7.5 from both sides, so we get our y-intercept, which is the same as this over here. So our y-intercept is negative, what is that, 12.5. So then our rule would be a sub n equals 1/2 n minus 12.5. Sorry, not minus 12.5, plus 12.5. Homework questions we'll do in class. And today we're going over, this is lesson 54, geometric sequences. So we're going to learn, what is a geometric sequence. Well, it's in a geometric sequence, the ratio of any term to the previous term is constant. And this constant ratio is called the common ratio. So before we had the common difference, which was d, the common difference. Now we're going to have the common ratio, which is r. The common difference we added or subtracted, and the common ratio we're going to multiply. And here's our general rule. And so what we're going to do is we're going to say that this is 5. What are we doing to get from one term to the next? We're multiplying by 5. So our common ratio is 5. So then our rule is going to be a sub n equals the first term 5 times, well, this happens to be 5 as well, our common ratio, to the n minus 1 power. So we can see, for example, if we wanted to know that the second term was 25, we'd say a sub 2 is 5 times 5 to the, that's our second term, right? First term, second term, third term, fourth term. So 5 to the 2 minus 1, we're substituting in a 2 for n. So that's 5 times 2 minus 1 is 5, and 5 times 5 makes 25, which is what we get. Our first example, write a rule for the nth term of the sequence. So what's going on from one term to the next? Looks like we're multiplying by 4. So our rule would be a sub n equals our first term 6 times 4 to the n minus 1 power. And it's as easy as that. So pause this and you guys want to try it, and then I'll do it. Write a rule for the nth term of the geometric sequence. So our rule again, a sub n equals our first term 4. How are we getting from one term to the next? Looks like we're multiplying by 3. So 4 times r, which is 3 to the n minus 1 power. The next one looks like we're multiplying by 6. So a sub n is going to be, first term is 1 times 6, our common ratio, to the n minus 1 power. Second example, finding the nth term given a term and the common ratio. So now we just need to plug in our information. So this is a sub 4 is a sub 1, which we don't know, times r, which is 4, to the 4 minus 1 power. Now, what did we say the fourth term was? The fourth term was 64. So really this is 64 equals the first term times 4 to the n. 4 minus 1 is to the third power. So we evaluate 4 to the third power. That's 4 times 4 times 4. Well, 4 times 4 is 16 times 4 makes 64. So 64 equals the first term times 64. So what does the first term have to be? First term must be 1, right? So we just solve for the first term, which is 1. So our rule would be a sub n equals 1 times 4 to the n minus 1 power. You guys try these. So this says a sub 1. This one's going to be easy. So this is a sub n equals, and now we're just plugging in, since it gave us the first term, that's going to be 2 times r, right? And our r is negative 1/3 to the n minus 1 power. So there's our rule. Our next one, we need to do a little bit more work. A sub 5 is a sub 1 times r, which is negative 1 to the n minus 1 power, but this is to the 5 minus 1 power. And what is a sub 5? A sub 5 is 3, so 3 equals the first term times negative 1 to the fourth power. Well, what is negative 1 to the fourth power? Negative 1 times negative 1 times negative 1 times negative 1. And this makes 1, and that makes 1, and 1 times 1 makes 1. So this is 3 equals the first term times 1. So what does a sub 1 have to equal? Has to equal 3. So then our rule then is going to be a sub n equals the first term, which we just found was 3 times r, which is negative 1 to the n minus 1 power. And our homework today is 54 from your worksheet.